Hello, chemistry explorers. Have you ever noticed how the fog in the morning lingers in the air? Or how milk looks opaque but isn't actually solid? These are just everyday examples of a fascinating class of substances we call colloids. Colloids are everywhere around us, from the food we eat to the medicines we take. They're mixtures where the particles are too small to see with the naked eye, but large enough to scatter light. This means that while colloids are different from true solutions, they are also distinct from suspensions. So, what exactly makes a colloid? Simply put, colloids are mixtures where the particle size ranges from about 1 nanometer to 1000 nanometers. These particles are big enough to be seen with an ultramicroscope but small enough to pass through regular filter paper. You'll find colloids in everything from gum arabic in candy to the paint on your walls. Let's dive deeper into how these systems are categorized. Now, let's break down the types of colloids. In the world of colloidal systems, the dispersed phase, that's the particles being dispersed, can be found in solid, liquid, or gas forms. Depending on the type of dispersion medium, colloidal systems fall into different categories. For instance, we have sols, which are colloids where solid particles are dispersed in a liquid, think of a paint or ink. Then there are gels, where the solid phase is the medium itself, giving us that jelly-like consistency, like in gelatin. What's interesting here is that colloidal systems, whether solid, liquid, or gas, are defined by their unique ability to not settle under gravity, which makes them quite different from suspensions. Have you ever wondered what gives the paint that smooth, even texture? Well, it's the colloidal particles suspended in it. Let's move on to understanding how colloids behave when mixed with other substances. Think about a jar of muddy water. When left to sit, the solid particles gradually settle to the bottom. That's a suspension. Now, imagine you've mixed something like gum arabic in water. The particles don't settle, right? That's because gum arabic forms a colloidal solution. Colloids and suspensions are both mixtures, but their behavior is very different. While colloidal particles remain suspended in the liquid, suspension particles are heavy enough to settle over time. And here's something cool. Colloidal particles are small enough to scatter light, which leads to the Tyndall effect. Have you ever shined a flashlight through a dusty room and seen light rays? That's the Tyndall effect at work, showing how colloids scatter light in all directions. Suspensions, on the other hand, don't show this light scattering as their particles are too large. So, the next time you look at a cloudy jar of paint or a foggy day, you'll know that's colloids showing their magic. Here's a fun experiment. What happens when you put a mixture of colloidal particles into a centrifuge? Normally, these particles won't settle under gravity, but when you spin them fast, you can force them to separate. That's because colloidal particles are much larger than those in true solutions but much smaller than those in suspensions. And yet, they still manage to stay suspended thanks to Brownian motion, which is basically the constant random movement of the particles. This behavior is what helps colloidal particles maintain their dispersion and not just settle to the bottom. Isn't that fascinating? When you look at colloids in action, whether it's through the light scattering Tyndall effect or the way they stay suspended in a liquid, you're seeing the unique properties of these small particles at play. Now, let's explore two very different types of colloids, lyophilic and lyophobic colloids. Lyophilic, or solvent-loving colloids, mix well with the dispersion medium. It's easy for them to form colloids because they have an affinity for water or other solvents. Think of substances like gelatin or starch in water. These colloids are easy to prepare and quite stable. On the other hand, lyophobic colloids are solvent-hating, meaning they don't mix well with the medium. These colloids need special methods to be formed and are less stable. For example, gold sol is a lyophobic colloid and it needs careful preparation to stay dispersed in water. The difference in how they interact with solvents is a major factor in how we use these colloids, from food production to medical applications. For instance, lyophilic colloids are used in foods like ice cream, while lyophobic ones can be used in more industrial settings. Let's connect what we've learned to real-world applications. Colloids aren't just fascinating for their unique properties, they're incredibly useful too. For example, in the food industry, colloids are used to create textures and emulsions, like in ice cream, where fat droplets are dispersed in water. In medicine, colloidal solutions are used for drug delivery, where the medicine is dispersed in a colloidal form to ensure it reaches the right place in the body. And let's not forget soaps. Soaps are a perfect example of colloids in action. When soap is added to greasy dirt, it forms a micelle, which encapsulates the dirt and removes it. From the paint on your walls to the cream in your coffee, colloids are all around us, making our lives smoother and more efficient. So, how do we prepare colloidal solutions? Well, there are two main methods: dispersion and condensation. Dispersion involves breaking down large particles into smaller ones to create colloids. This is done using machines like colloidal mills. On the other hand, condensation methods involve aggregating smaller particles to form larger colloidal particles. For example, you can create a colloidal solution of sulfur by breaking down solid sulfur into tiny particles that stay suspended in water. Both methods allow us to create colloids for a wide range of uses, from industrial applications to health solutions. So, to sum up, the colloidal state is a fascinating class of substances with unique properties. Colloids are mixtures where particles are larger than those in true solutions but smaller than those in suspensions. These particles remain suspended and can scatter light, a phenomenon known as the Tyndall effect. We explored different types of colloids, from lyophilic to lyophobic, and saw how they play a huge role in industries like food, medicine, and even cleaning. Understanding colloids helps us appreciate their real-world applications, from the food we eat to the way we use chemicals in our daily lives. Thanks for joining me today, and I hope you now see how chemistry is all around us, in everything we touch and use.